Good morning. Today we are here with Aria the Amazing Experimenter, and we are going to be doing an aluminium experiment. We're going to make the aluminium. Well, we'll see. We'll find out. But here to introduce the clever stuff, tell you all the chemical information that you need to know about this experiment is Professor Aria. Back to you at the lab, Professor Aria.
Some metals are more active than others, meaning that they are more inclined to abandon their chunk of metal for the solution to engage other chemical reactions. Chemists have carefully measured this property and assembled a chart known as the reactivity series. In general, if you take a solution containing ions of a metal and put a piece of more reactive metal on it, the ions will switch places. The more reactive metal will go swimming in the solution, while less reactive one will take its metallic form. As you know, aluminium or Al is much more reactive than copper, Cu, but nothing happens when aluminium foil comes into contact with copper sulphate, CuSO4 solution. How come? Unfortunately, it's all a bit more complicated than it looks. Being quite an active metal, aluminium Al reacts with oxygen O2 in the air, forming a very strong film of aluminium oxide Al2O3. On its surface, the film protects the metal from reacting any further. When you add some sodium chloride, NaCl, a vigorous reaction starts, and you can clearly see a brown-red copper metal flakes forming. But why? Ci ions are able to compromise the otherwise strong aluminium oxide. The layer on the foil's surface and allow some copper ions in once the Cu2 is face to face with the aluminium itself. Not its Al2O3 shield, the reaction can proceed quite spectacularly.
Ladies and gentlemen, boys and girls, that's why she's the professor and I'm not. I don't know how you guessed I'm not, but I'm not. Well, basically what she was saying in unprofessor terms is that you get a roll of tin foil that's not actually tin anymore, not since the age of World War II. Mind blown. Why do we call it tin foil? Well, we just like our traditions, I guess. Tin foil, if you can still get it, it tastes a bit tinny when you put your food in it. So generally we don't cook with it anymore, but you can still if you want to, I'm sure. Today we have aluminium foil. Aluminium foil is the most common one you can get from the shops. Now, aluminium, as she quite rightly said, in some professor type terms, as soon as you get the aluminium out, the oxygen in the air reacts with the aluminium and it makes a protective force field where the copper cannot penetrate. But with a little chemical magic, we can sprinkle some table salt, which is called sodium carbonate. Is that right, Professor?
I think so.
There we go, the professor says it is, so it is. We sprinkle some salt on and it destroys the force field.
But one more thing we need, water.
Water, definitely. Well, I don't know how the experiment works. I'll let the professor guide you through that. So, hold your horses, guys and girls.
Okay, so this is how you do it. You want to listen?
Yay! The experiment time!
Okay, so first we're going to get a little special cap. And then we're going to put it in the middle. Like...
Of the aluminium foil.
Yep. Of the aluminium foil. Going to wrap it round.
So we're going to make a little pouch. Whoa!
Yeah. So, we're going to take this one out. Well, we can leave
Let's
it
see
in
the
if we
pouch.
want.
Oh, in the pouch goes and over the glass beaker. Go fill your water.
Like so. Okay. That's a nice one. Maybe if we lift that up a bit and there. We don't need to make a hole in the bottom. See? It'll make a hole itself.
Here you go, Professor. Here is the H2O, otherwise known as water. I'm clever. Oh, I knew it. H2O.
If you're so smart, do you know the next step?
No, what's the next steps, Professor?
So, we get our copper sulphate.
Copper sulphate?
Yes, we do. We're going to take...
Wow, it's blue.
Yep. That was that pretty color. 2 little spoonfuls. Okay.
What's next, Professor?
So, we're going to add some salt. Oh, sorry. I mean water. Oh, let's see. If I use my little device, water.
So how much water's going in there, Prof?
3 milliliters.
3 milliliters, whoa.
So, let's get...
Carefully pours it in. Down the water goes into the blue copper sulphate.
There we go.
Can we get a close-up? Whoop, whoop, whoop. Whoa, that's looking cool.
What do you think we should add next? Should we add...
Oh, is that sugar?
Nope, this is salt.
Salt! How didn't I know that? I wondered where it had gone. I was looking for some last night for my chips. Oh, and that's 2 spoonfuls of salt going in there.
Yep.
And now, what's gonna happen?
I think it's gonna make a little hole in the bottom.
Ladies and gentlemen, boys and girls, the experiment is working. How did the water get through the tin foil? Magic! I'm sure it's got to be magic. Ain't that right, Professor?
It's not magic, it's science.
Science? Whoa, science is cool.
Yeah.
You didn't put any holes in that tin foil, and it's gone all the way through.
Yeah.
Wow, and it's not blue anymore either. The top's gone like a green color. What color would you say that is?
I'd say that is white and bright green and a bit of red.
Whoa.
It's not the bottom we need, it's the top. As you can see, it's crystallizing in the top. And everything's turning to metal. And it's rusting the aluminium foil.
So this is called a foil etching. Oh my gosh, look. You can see, oh my gosh, I caught it on camera. We melted that metal away. How awesome, dude.
Yeah.
Foil etching. Bum, bum, bum.
That is really cool. So, just to watch it in real life is
Can you tell us what you think about it, Professor?
good. So, now, tomorrow I think we're going to do another one, but for today I think that's it. So, let's have a look. Proper look. That is really cool.
How it just went straight through the tin foil.
Yeah.
Now, so ladies and gentlemen, boys and girls, now you know that you have the power to get through Iron Man's suit. Isn't that... Oh no, actually, why is he called Iron Man? I guess it's because his suit's made out of iron. And we just found out how to melt aluminium using magic. Isn't that right?
It's not magic.
Oh yes, science.
Science.
Okay, fantastic science to melt through aluminium. But for next time, maybe we can think of how to melt through iron. 'Cause then we could destroy Iron Man's suit.
Yeah. I think that sounds like a good idea. Bye. This is like goo.
Whoa, dude. It's Pac-Man! It's Pac-Man's cousin! He's green! Well, I'm back onto the tin foil.
I wonder what happened. I think it's going through it, you know.
Whoa.
I can hear it fizzing. It is.
Kryptonite.
It'd be cool if it was. This filter paper is going soggy. It's really soggy, this filter paper. It's totally disappeared. Look. Oh, that green. Poof. Gone. And for this poor filter paper. That is really cool. Oh my god. I need to keep this as a memory. Oh! Oh! It's like fool's gold in the camera.
Whoa, it's burnt right through it again. Oh my days, this reminds me of the Alien film. When one of the little aliens dies, like this acid stuff comes out their skin and it melts through the whole spaceship, dude.
Let's try it. If we put it on here. If we dampen it down.
This is why Iron Man had a suit of iron and not aluminium. Because you can use magic to just burn through aluminium.
It's not magic.
Oh, sorry, science, dude. Sorry,
Science.
Professor.
And what happens if we put it on either side? Let's see. Nothing's happening to one side. This is so cool.
It's burning through again, dude.
Let's see if we can get a little drop more.
And remember, kids, stay safe. All these things come with a warning. You get me?
Yep.
This is Professor Aria saying peace out. Stay blessed, dude.